Okay, 3, 2, 1. Assalamu alaikum wa rahmatullahi wa barakatuh. Welcome back. Hello, and we are recording another session. We have another quiz coming up on Tuesday, and inshallah it's going to be the last one for the year. The last one for the year. The year just flew by. Didn't it just fly by? It just feels like yesterday, subhanallah, we started, and now it's the last quiz for the year. Okay, well, let's make khitamuha misk. Let's inshallah make the last one the best one. Okay, what I want you to do is I want you to pay attention with me, and inshallah we're going to get through this, and it's going to be a quick revision session, and you're all going to do really well on that quiz. Let's have a look. So quick notes. The first thing I want you to do is I want you to make sure that you pause the video, and attempt to do the questions before observing the solution. So what you do is you pause it, try to do it yourself. You've got the formulas over here, and then you unpause it or you play it and see if you can get the right answer. And of course you will be given the formulas in the quiz, so I don't want anyone else to ask me, will we have to memorize the formulas, or are we going to be given the formulas in the quiz? You will be given the formulas. Of course it's good practice to learn them, but you will be given the formulas for the upcoming quiz. Okay, now with that out of the way, let's start doing some revision. Bismillah ar-Rahman ar-Rahim. So what are the units for energy and power? So that's the first thing I want to start with. Obviously, there are units for things. For length, if we're measuring length, then it's meters. Meters are the symbols, the units are meters. Energy has a unit. Energy and work are synonymous. So that means is basically when you hear the word work and when you hear the word energy, they're very much the same, okay, for all intents and purposes. And the unit is joules, and the symbol is J. Okay. What about power? Power. Okay, there's an old joke about that. What is the unit for power? What is the unit for power? Get it? Okay, well, unit for power is watt. So am I asking a question or am I saying a statement? What is the unit for power? What is the unit for power? That is a full answer. So it is watt. Okay. So if we say something is 50 watts or 100 watts, watts are the units for power. Moving on, kinetic energy. Let's talk about kinetic energy. So kinetic energy is energy for motion. Okay, so that is the energy associated with motion. So if things are moving, then they have kinetic energy. If things are moving, they have kinetic energy. If things are not moving, if they are stationary, then the kind of energy they have is probably potential energy, whether it's one of the 5 potential energies, but we'll talk about it in a minute. But if things are moving, then they have kinetic energy. Now, what are the things that determine the amount of kinetic energy an object has? So let's say, for example, I have 2 objects. I have a small ball and a big ball, and I throw both of them. Which one will have more energy? Well, it depends on 2 different factors. It depends on the mass of the object, as well as, and what else does it depend on? The speed, or the velocity to be more correct. Okay? And the formula looks like this: half mv squared. That is the formula for kinetic energy. Half mv squared. Now what that means is if you know the mass of the object, if you know the mass and you know the velocity, or how fast it's traveling, you can work out the amount of kinetic energy the object has. Simple as that, really. Very, very simple, very intuitive. Okay, so it's the energy that has to do with motion, with movement, and it's got to do with mass, and it's got to do with velocity. Okay, which is why bullets, even though they're quite small, they have a small mass, they're traveling at very, very high velocities, and they have a lot of energy that can actually kill someone. Okay, let's move on. Now I've got potential energy. Potential energy is the energy that has to do with position and shape, and I'll talk about that in a minute. So what that means is we've got potential energy is divided into 5 different categories. 5 different categories. We've got chemical potential, which is the stuff in food. Okay, so that's chemical potential energy, and I'm going to draw a slice of cheesecake. I think I feel like cheesecake. There you go. So that is chemical potential energy. We also have elastic potential energy, and that is what we find in springs and rubber bands. Elastic potential energy. We also have electrical potential energy. Electrical, and that's the stuff we find in batteries. Okay. We also have, what else do we have? We've got gravitational, and that is gravitational potential energy, and that's the one that's got to do with height. So objects that are sitting high up, let's say on top of a cliff, have a lot of gravitational potential energy versus when they come down. So let's say, for example, this ball here is sitting right up there and there's a cliff underneath and water. Okay, so when that ball is up there, it has a lot of gravitational potential energy. But just as it hits the water, it doesn't have a lot of gravitational potential energy because it no longer doesn't have any height. So now it's got kinetic energy. Some of that, and then halfway it's got like a little bit of gravitational potential, a little bit of kinetic energy. But the most kinetic energy it's got is right before it hits, because then it doesn't have a lot of height at all. And the most gravitational potential energy it has is right on top there. And there's one more potential type of energy that we can talk about, and that is nuclear potential energy. But we won't worry about nuclear potential energy too much. We'll just call it nuclear, I think it's with an A, nuclear potential energy. And let's see if I can draw the nuclear symbol. Let's see if I still remember how to draw the nuclear symbol. Fallout fans? Anyone here is a Fallout fan? Anyway, moving on. So that's as far as potential energy is concerned. Of course, energy is energy. They all have the same unit. It's all measured in joules. But when it comes to gravitational potential energy, height is very important. Okay, let's move on. Bicycle versus car, which one has more kinetic energy? Now we're getting into the question. So we've got a bicycle. Okay. I haven't drawn a bicycle in a while. Let's see if I still remember. There we go. There's a bicycle, and we have a car. Of course, I am rushing, so they're not the most beautiful bicycle and car drawings that I've ever made, but that will do. So there it is. Car versus bicycle. Which one has more energy? Well, it depends. Remember, kinetic energy is the one we're talking about here. Kinetic energy. So that has to do with, look, that has to do with mass and speed. So there's missing information. It's easy to say the car will have more energy, but what if the car is not moving? What if the car has a velocity of 0 while the bicycle is moving? Then the bicycle will always have more kinetic energy, even though it has a lower mass. So the bicycle might have a mass of 30 kilograms, while the car might have a mass of 1,500 kilograms. But if the car is not moving, then the bicycle wins. Okay? So it depends on the velocity. What if the velocity of the car is 2 meters per second? Then who wins? Well, now we have to work it out. But you also don't have to work it out. With this much mass, the car wins. But we can work it out using the calculator. And of course, you do need a calculator for the quiz. You do need a calculator. Let's have a look. Half mv squared. So 1 times 1.1 squared. Let me show you what that looks like. Kinetic energy will equal half times m times v squared, which equals half times 1500 times 2 squared, which equals 2250000 joules. Now that is a lot of joules. Am I doing this correctly? Did I do something wrong? It almost seems like I did something wrong. Of course I did. Yes. My calculator was acting up. No, that's only 4 times 750. So that's 3000 joules. Oops, that's why it's important to check. What about the bicycle then? Same exact scenario. Half mv squared, which equals half times 30 times 9. And that should be 135. I'll just check that anyway. 135 joules, yes. Okay, so it depends on the mass and the velocity. If somebody tells you which one's faster, you say, what's the mass and what's the velocity? Then I can work it out. Next, let's do some calculations. A 10 Newton book, so this here is the weight. 10 newtons is the weight. A 10 Newton book sits on top of a large bookshelf, as you can see here. It's right there, which is 3 meters tall. Calculate the gravitational potential energy. Well, look here, that's the formula for gravitational potential energy. It's simply weight times height. Gravitational potential energy equals weight multiplied by height, which means it's going to be 10 multiplied by 3, 10 newtons multiplied by 3 meters, which is going to equal 30. What's the unit? Joules. Okay, 30 joules. Now someone might say, well, hang on. Doesn't weight have a unit of newtons, and height has a unit of meters? Can we just say Newton meters? Yes, you can. You really can. So instead of joules, you can say Newton meters. But don't worry about this sort of thing now, because that's more for grade 11. For now, just remember, energy has a unit, and the unit is joules. Let's move on. So once again, I'll remind you, please try and do it before I do it. So pause the video if you have to. A crane carries a 2,500 Newton piano. So once again, that is the weight. To the second floor, which is 4.2 meters high. So once again, that's the height. Calculate the gravitational potential energy of the piano. So hopefully this should be quite easy by now. All I have to do is use that formula. Gravitational potential energy equals weight multiplied by height, which equals 2,500 newtons multiplied by the height, which is 4.2 meters, and that equals, well, about 10,400 or something times 4.2, so 10,500. What's the unit? Joules. 10,500 joules. Okay, hopefully that wasn't too hard. Let's move on. A 5 kilogram cat, so this cute cat over here is 5 kilograms, and it's running at 1.5 meters per second. Calculate the kinetic energy of the cat. Once again, we have the formula. So kinetic energy is equal to half multiplied by mass multiplied by velocity squared. So it's going to be half multiplied by the mass, which is 5 kilograms, multiplied by 1.5 meters per second squared. And I'll just put all of that into the formula. 2.25 times 5 times a half, which is about 6. So let's have a look. Half times 5 times 1.5 squared, and that is 5.625 joules. That's the answer. Okay, so you do know how to use it. You do need to know how to use a calculator. Okay, excuse me. You do need to know how to use a calculator. So make sure that you've got your calculator. Make sure you're not scrambling to borrow a calculator on the day of the test. And I'm talking to very few boys that are watching. Please make sure you have your calculator and you have your pen for the quiz. Oh, let's have a look. Now we're talking about the power ones. A 30-watt light bulb is on for 100 seconds. How much energy work done has it consumed? So once again, the formula is right here. Power, or another way of doing it is like that. Power equals energy over time. So if you prefer triangles, or you can write it like that. Power equals energy divided by time. So what do we have? We've got the power. How do I know that's the power? Because it's in watts. So I've got the power, and I've got the time, which is 100 seconds. So really the rest is history. So all I have to do to get the energy is I have to multiply the power by the time. So energy, more power, more passion, equals power multiplied by the time. And I do have both of those things, so it's going to be 30 watts multiplied by 100 seconds, and that will give me the energy, which is 3,000 joules. Don't forget, the unit is joules. Hopefully you got that one right. Okay, moving on. A 500-watt electric jackhammer is used to break a wall. How long before it completes 2,500 joules of work? So once again, just give me a second. So how long before it completes 2,500 joules of work? Let's have a look. So once again, it's going to be the same formula. Oops, let's go back. The formula is power equals energy over time. We've got this, which is 500. We've got that, which is 2,500 joules. We don't have this. That's what we're looking for. How long? So we're looking for the time. So the time is going to equal energy over power. Okay, so it's going to be 2,500 divided by 500, which is going to equal 5. 5 what? What's the unit for time? What's the unit for time? The unit for time is seconds. So that's the answer to that one. Okay, hopefully it wasn't too hard. What is the power rating of a vacuum cleaner that completes 3,000 joules of work in 5 seconds? 3,000 joules. So that is immediately energy. How do I know that that's energy? The units, guys, the units. It's easy. So joules right there, and then of course I've got the time, which is seconds. So what do I need? I need the power. Power equals energy or work done over time. So that's going to be 3,000 divided by 5, which is 600. And what's the unit? I just said it. What is the unit? Watts. Or 600 W. Moving on. Let's talk about pendulums. Easy peasy lemon squeezy. So with pendulums, as you can see, it sways back and forth. Now, it's got a lot of kinetic energy as it's swaying. But how much potential, does it have any other types of energy? Yes, it does have gravitational potential energy, especially when it's high up there. So at this stage here, it has a lot of gravitational potential energy and very little kinetic energy. In fact, at one stage it has 0 kinetic energy when it stops moving completely. So it goes up. Let me just try and pause that properly. Let's see if I can pause it at that point, which is not going to be easy, but let me try anyway. Can I do it? I tried. So there's the point at which it has a lot of gravitational potential energy. Now when it comes down here, it has a lot of kinetic energy. Over here it has a lot of kinetic energy. But what about up here? What about up here? What kind of energy does it have? So once again, it has a lot of gravitational potential energy. So at this point here and at this point here, it has a lot of gravitational potential energy, and in between it has a lot of kinetic energy. And of course at this point it has sort of like got a bit of gravitational potential and a bit of kinetic. Over here it's mostly kinetic because there's not a lot of height at all. Over here once again it's kinetic and gravitational potential, and over here it's almost purely gravitational potential energy. Okay, so just remember, bring your calculators. As I said, please don't forget to bring your calculators, and you don't have to memorize the formulas because they will be given to you in the quiz. Best of luck. See you. Bye.